yeah, your domain, in this case, domain goes out forever. It's kind of tough to see. It doesn't, and this almost looks like a straight up vertical line, but it does extend indefinitely to the left and definitely to the right. That's where you get your negative infinity to infinity. I like the script R there. And then range, lowest to highest. Please don't write 7 to negative infinity. I might not like that one so much, so do be careful there. Let's move on down to the next one, and again, do some domain and range stuff to get started. I do want to point out that the function does seem to have a maximum here, and that maximum looks like it's about, we'll call it 5. So that'll be our maximum for this function. So try and figure out the domain and range of this one. So the domain goes along with which coordinate?
X.
So the x coordinate. So our x coordinates that are graphed, well, it starts here and goes over to here. Let's see, who haven't I picked on yet today? Kaylin. What's the domain going to be here, please?
I said it was -3 and 4.
Brackets or parentheses?
Brackets.
Nice, brackets. -3 to 4, cool. Let's see. Nick, how about the range, please?
It would be bracket 0 to 5.
Yep. So everything in the y direction, bracket 0, comma 5. But now we want to look at a new property where a function is increasing and decreasing. Lucas?
So in the question before, for range, we did negative infinity 7, but this one we did 0, 5. So do we go up, down, or down, up for the y coordinate?
Bottom to top. So I think we were consistent in both of them, right? Because we went from negative infinity is going to be at the bottom here.
Infinity is 7.
Negative infinity, so bottom to top, 0 to 5. Okay? Appreciate the question. Let's follow it up with where a function's increasing and decreasing. Now this one, your answers are going to be intervals along the x-axis. So
would it be
answer
0?
in intervals
Would be 0.
along the x-axis. So your answer is not really going to show anything about the y's. It's going to tell things about the y's. But let's look at this function starting at -3. What's happening to the function as I move closer to the origin?
Decreases.
It's decreasing. So it's decreasing from -3 to 0. So let's write that down. Now, I have a little bit of a philosophical difference with the book in this one. So I am going to show you how WebAssign does it. So it's decreasing from -3 to 0. Now 0 is kind of a transition point, right? Because after you get past 0, what starts happening with the function? Starts increasing. So it starts increasing until we get up to about here. So at 0, the function's neither increasing nor decreasing. So I'm going to put a parenthesis there. Now, if it were up to me, I would just write all your problems with parentheses for increasing and decreasing. WebAssign, I think, is going to put a bracket on -3 because it's not exactly a transition point from decreasing to increasing or increasing to decreasing. So that's why they're putting that little transition point there in parentheses. Now, what happens after we get past, say, I don't know, let's call it 2.8? What happens there? Let's call that 2.8. Yeah, so it's increasing from 0 to 2.8. And if I give you something like this and it's not perfectly clear and perfectly on a line, I'll give you a little wiggle room. I mean, if you did 2.7 or 2.9 or something like that, that's fine. I'm not going to be too picky. If you did 2.2, 2.1, I'm going to start to get a little unhappy because it looks like it's more than 2.5. So 0 to 2.8. But then what happens? Starts decreasing again. So that's going to be this part right here.
2.8 to 4.
Union, actually parentheses 2.8.
2.8 to 4.
2.8 to 4,
Bracket.
and 4 gets a bracket because it's just an endpoint there. So, like I said, I'm not really thrilled with the brackets, but I'm pretty sure that's the way WebAssign rolls on that one.
So you prefer if we do parentheses?
You know, you can use brackets here like that. That's fine. I mean, on a test, I'm not going to worry about the endpoints so much as I will these middle points. You can't include the 0, you can't include the 2.8 because those are kind of like transition points where the function goes from increasing to decreasing. Let's move on down. So again, we're going to practice domain and range here real quick. Well, let's look at this function and try and understand what this looks like. We've got the graph of f of x equals x squared minus 5 for values of x between -3 and 3. What's the general shape of this graph that you expect here?
Parabola.
Parabola. Good. Now, in particular, how's that parabola going to be shifted compared to the graph of x squared?
Towards negative. So
Yeah, down by 5, right?
Yeah.
You can plot some points here. It's not a bad idea. So if you wanted to, you could plot, say, -3, 0, and 3. Those would be some nice points. 3 squared is 9, minus 5 is 4, -5, and 4 again. You'll notice I've already got a couple of those points drawn for you. So they're here and here. Let me continue that graph. And I apologize for making your head spin here a little bit. There and there. So you get just a little bit of a piece of the parabola. Why don't you try and figure out the domain and range based on this? Just looking at the graph. What's that? I just thought it was cute that you put your phone behind your calculator.
I don't know what you're talking about, but
So the domain is kind of a freebie, right? Why is the domain a freebie? Why don't I even have to think about the domain?
-3 to 3.
It's not all real.
Oh.
It's given to you right here. It's -3 to 3. That's -3 to 3. So that part of it's kind of the freebie part. The other part that you're going to have to think about is the range.
-5 to 4.
-5.
All right. -5 to 4. You get that by looking at the y-axis and seeing where it's graphed. Now you know what the coordinates of these points are. I mean, you can get that a couple ways. You can look at that and say, all right, that's a 4. Or you can look over here and say, all right, at x equal -3, you're at 4. So -5 to 4. And Lucas, I think again, we're being consistent. We're going from bottom to top, right?
Yes, sir.
Cool. Thank you. All right. Yes, go ahead.
Why is it a bracket for -5?
Because the function actually does get down and touch the graph at -5. So this would be, included. So the function actually does equal that, as opposed to, say, if I had a different type of function, let me say, suppose you add x over x plus 1, if that was your function. think about the graph, think about the values that you would put into this function. You could put in values like 10. So if I put in 10, I get 10 over 11. If I put in 100, I get 100 over 101. So this gets close to, but never quite touches what number? Yeah, it gets close to, but never quite touches 1. And if you looked at the graph, you would see exactly that. You'd see that 1 is not actually part of the graph. So let me shut these down. And let's shut that one down too. And let's look at the graph of x divided by x plus 1. And you can kind of see it. This graph gets close to, but it never quite touches 1. So your range in this would be like negative infinity to 1
I thought
with parentheses.
I thought it went touch -1.
You're thinking of the domain. I'm talking about the range. The y values never quite get the 1 here, and never quite get the 1 here. So 1, y equals 1 would be excluded from your range. So it's important to know, is that point included or not? And with this graph, yeah, at x equals 0, we actually do get down to the point -5. So good question. Let's do another one to follow up on this one. Tell me where it's increasing and decreasing. Now let's give people a second. Now keep in mind that you have to answer in terms of intervals on the x-axis. Don't give me, it's decreasing from the point -3, 4 to 0, 0, or 0, -5. I don't want that. That's not the way you're going to input your answers on WebAssign. That's not the way you're going to put your answers in on the exam. So, Ryan C. I think I've got all the Ryans now today. Where is it increasing? That's in the y-axis. That's in the y direction. Where is it increasing in terms of the x's? Well, it starts increasing at what value? At 0, right?
Yes.
So the increasing part would be 0 up to 4, actually 3, right? 0 to 3. 0 is that transition point. So we'll get a parenthesis. 3, according to WebAssign, gets a bracket. How about where is it decreasing? Again, keep in mind, we've got to report this in terms of intervals along the x-axis. So it starts decreasing here all the way to here. -3 to 0. Actually, I got that backwards. Yeah, I got that backwards. Man.
-140. Your way out.
Yeah. Need some grief. All right, so let's just do this. There we go. Never happened. Beautiful. So -3 gets a bracket, 0 gets a parenthesis, because it starts increasing, it starts decreasing at -3 to 0. And then 0 to 3 is where it's increasing. Great. Ryan, are you feeling better about increasing and decreasing there?
I just don't get why it has to be on the x-axis.
That's just the way we do things in math. Yeah.
That's what it is.
We're not going to talk about where it's increasing and decreasing in terms of the y-axis. We're just going to talk about it in terms of the x-axis. So let's move on to example D. And I want us to look at the domain of this, first of all, with the graph. Now, you can do this with your graphing calculator. That's fine. I'm gonna do it with Desmos because it's just so much easier. Quick pro tip about square root function. If you want a square root function, you can hunt for it from the keyboard. That's fine, nothing wrong with it there. I always just type in SQRT, square root, x plus 2, or x minus 2, right? X minus 2. So there's your graph. Wow. So see if you can't determine the domain and range just based on the graph.
Does that line go on forever?
Yes, it does. So if I zoomed out here, so you can see that it keeps on going on and on and on forever. So yeah, there's nothing that stops that in either direction, really. And by either direction, I mean to the right or up.
0, 2.
All right, so Johan, where's the domain start?
Excuse me a second.
You can look at the graph.
2?
Yeah, at 2. Now, am I going to include 2 with a bracket or exclude it with a parenthesis?
Exclude it
Okay.
with a, wait,
Can I plug it in?
with a bracket, with a bracket.
Oh, no, it would be
Yeah.
a parentheses, because it'll be
Okay.
0. Oh,
Well, can you take the square root of 0?
Yeah, it's just
No.
zero.
Square root of 0 is 0. So
Oh.
there's nothing wrong with that. So 2 to infinity for the domain. How about the range? What's the range going to look like?
0 to infinity.
Range is your y coordinates.
0 to infinity.
Good. Lowest to highest, 0 to infinity. So bracket around the 0 to infinity. Let's take a look at the domain in a different way. So that's looking at the graph and getting the domain that way. Another way to get at the domain is to realize the restriction here. We need to make sure that x minus 2 is greater than or equal to 0. Well, how does that solve? What do we do to solve x minus 2 is greater than or equal to 0? Add 2 to both sides, so x is greater than or equal to 2. And that matches what I have here. So, cool. All right, let me throw you a curveball then. I want to know where it's increasing.
Oh, no.
You could have anticipated this. And decreasing. Now I'll put the graph back up here. So increasing and decreasing. And give that your best shot. Now the graph, as I've shown it, continues this way like forever.
So where it's increasing and decreasing.
Increasing and decreasing is always judged from left to right. So don't look at it 2 directions. Good. Just so you know, if you put your cursor on this and shift key, then you can then you can just scroll in on one axis opposed to both. So it's really helpful. Fine here between 0 and 2. So what's happening in the function is as you move from left to right, the function is going up. Where does it start going up? At 2. Right? So it's not defined at 0. So it starts at 2. And then it's increasing from there. Nice. All right, so in terms of increasing and decreasing, well, let's start with the increasing. So starting at, I don't know, x equal 2, what's happening to the function? It's increasing, right? So 2 to infinity. Now, I'm going to be pretty lenient here. You could do parenthesis or a bracket. I think WebAssign would do a bracket. Why I feel like I want to put a parenthesis here. I'm not going to worry about that on the exam. But how about decreasing? What should I write there?
Undefined.
So is it decreasing anywhere?
No.
No.
No, it's always increasing. So a couple things you could write. You could write an empty set, or you could write the null set. Empty set or null set, empty set. They mean the same thing. It's not decreasing anywhere is really what's going on with that. All right, let's keep rolling. Now we're getting to the point, or closer to the point where we're gonna want our graphing calculators. I hope you have those out. Let's move into things gently with this first example here. So example E. And let me come down to this here. So this is a little bit better place to see things. And let me zoom out just a I'll just leave it like this. That's nice and big. The first question then is, which is bigger, f of 0 or g of 0? Good question. Well, how do I tell what f of 0 is? They didn't give me the definition of the function. How do I tell what f of 0 is?
Go to 0 on the x-axis.
Yeah, we want to look at the function for f and go to 0 on the x-axis, or on the y-axis, really. So we'll 0 along the x-axis and find out the y-coordinate there. So there's f of 0. Is that going to be bigger than g of 0?
Yeah.
Yes.
Yeah. So f of 0 is bigger than g of 0. F of 0. So the next question is, at what values are those two equal to each other? Where does f of x equal g of x? What should I see when f of x equals g of x?
2.
They're at the same point. They cross each other, right? They intersect. So that's going to be here and here. And then you just need to list the x values for those. I'm not interested in the y values for this particular problem. So it's going to be x equals what? -2 and 2. Nice. And finally, we want to know what values is f of x greater than g of x. So let's look back here at the function. Be a little easier to see here. So let's look at this graph. To the left of -2 is f bigger than g. Let's see, was it?
Is it then?
So actually it's g is bigger than f to the left of that. How about between -2 and 2? Is f bigger than that? Is f bigger than g? Yes. So for those values, and I clicked the wrong thing here. Here we go. So for these values between -2 and 2, that's where f of x is bigger than g of x. Now, the question that you need to answer correctly is brackets or parentheses. On the test, that it's only 1 point off. On WebAssign, it's just wrong. So what's the right answer here? Brackets or parentheses?
Parentheses.
Why parentheses?
These both share at the points
They both share.
two,
So
so they're the same, they're not bigger or smaller.
Yeah, so at -2 and 2, they're actually equal to. So I don't want those, because I want to know where f is bigger than g, and that's between these values. So we'll use parentheses on that. Now, we're gonna have to do something similar for the next one, and we're gonna bust out our graphing calculators. Before I move on to that, are we okay with this one?
Yeah, easy.
Okay,
Don't say that.
so,
Make it harder.
yeah, well, the harder is coming your way either way though, so. Here we go.
Uh-huh.
I wanna solve where these two things are equal. So I've got x cubed plus 4x squared, and I want to know where that's equal to negative x squared plus 3x plus 5. And here's how we're going to work this one. I'm going to put this first function in y1 and the second one in y2. Okay, and then we're going to graph it. So let's bust out our calculators. Let me clear out some old stuff here. You're gonna go to the y equals key, clear out the old stuff. Let's see, clear, and clear again. And let's type in these functions. So the first one is gonna be x cubed plus 4x squared. So it's gonna look like this, x cubed plus 4x squared. Make sure you hit the right arrow to get out of the exponent when you type in the x cubed. Press enter. Let's plug in the next function, negative x squared plus 5x, or plus 3x plus 5. Thank you. Now you got to decide where we're going to graph this. So let me give you a big hint. You don't have to reinvent the wheel on this, right? You've already got a graph staring you in the face. Why not just steal the settings for this one? What should I use in the x direction? So negative 6 to 4. So negative 6 to 4 in the x direction. And how about in the y direction?
That's 6.
Well, you
What
were,
in the y direction? Negative 50 to 50. So x min, x max, y min, y max. Let's use those settings. There's no point in kind of reinventing the wheel here. Just going to borrow those settings. I've already got my negative 6 here. Let's go up to 4. I didn't mean to press that. 4. And then on the y direction, I want to go negative 50 to 50.
the scale.
I probably don't want to leave y scale as 1 because that would make my graph a big mess. All right, I wouldn't be able to see things very well. I mean, I can punch it. See how crammed it is here? So let's go back and set y scale something that's nicely divisible into 50. 10 seems to jump out. You can use 25 if you want something even coarser. Now I hit this and it looks a little bit better. So the graphs look like this. This graph here is my parabola. And then I've got the other graph, which is the cubic function. And the first question that is being asked in this problem is, where do these graphs intersect each other? So this is going to be your challenge on the exam. So this Monday, I won't have time to do a review, but I'm telling you, this is something that you should expect, period. All right? So not a surprise for you. You want to know what's on the exam? Something like this. Let me clear out my key history here and follow along. You should be looking at the graph on your calculator. To find the points of intersection, start by hitting the second key, then the trace key. That takes you to the calculate menu. Is there anything at the calculate menu that looks promising? Intersect, yeah. Let's go down with intersect.
Which key did you hit again? Did you get
Second key, then the trace key.
the trace key? Okay.
So just a quick FYI, my key history is right here, so you can always look back and see what I've been using. So I'll select number 5. And this, it works a little bit funny. It's not bad. You just got to get used to one little thing. It says, all right, give me approximately where you think this curve is going to intersect. Let's go for this point down here. So I'll scroll over here. And you just got to get close to the point of intersection. You don't have to be right on top of it. Doesn't matter. And once you get close to it, you're going to press enter a total of 3 times. You're going to press enter to give it a guess as to where this point of intersection is from your first curve. And then from your second curve, for reasons that I'm not going to try and explain, it wants another guess. So just press enter again. So you're going to press enter a total of 3 times. And that third time, it should give you the intersection. It should give you the X and Y coordinates of that point. Is everyone able to get negative 5.38 something? All right, so let's put that down. That's one of our points of intersection. Negative 5.38.
You got it.
5.38.
Oh, you got completely.
Want to try that one again?
I don't know what I did. I was trying to zoom out a little bit so that I could see that point that we're on.
Let's try that again. So this time I'll get this point here near negative 1. So go back and let me clear out my key history so you can kind of follow along again.
It's actually not even there anymore.
Second, calculate. You want intersect. This time scroll over towards that point of intersection. You can actually type in a number if you wanted to. You want to just kind of jump to that point. What do I have to do now?
Oh, I think that's.
Press enter 3 times.
I know what I did wrong. Because I tried to zoom out to use like the zoom thing and then it
Okay.
changed my.
All right, so you press enter 3 times and bam, you get about negative 0.79. So that's the next one. So this point here, actually I didn't maybe do a great job of drawing that. Negative 0.79. And the last one, just to kind of speed things up here, that's going to be about 1.17. So those are where the graphs are equal to each other. So that's the first part of your problem, and it wants you to enter your answers as a comma-separated list. Okay, great. The next part says, where is this function greater than or equal to this one? So it's asking, where is this graph right here greater than or equal to the parabola? Now you have to answer in intervals along the x-axis. Sorry, Ryan. We're stuck with the x-axis again. So this is why we do these problems in order. We found where they're equal. Now we can find where the pink function is bigger than the yellow function in terms of the x-axis. So is the pink function bigger than the yellow function to the left of negative 5.38?
No.
No. How about between negative 5.38 and negative 0.79?
Yes.
All right, so this interval needs to be part of my solution. How about between negative 0.79 and 1.7?
No.
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 No. How about between 1.7 and infinity?
Yes.
Yes.
So try and list those values of x that are kind of highlighted in blue, right? Those are your answers. So you just need to give it an interval notation. Give you a second to think on that one before I see that Brandon's anxious to volunteer. Thank you, sir. Appreciate you stepping up. Brandon's bewildered that he volunteered without raising his hand, but it's because I knew that you wanted to volunteer, so it's a good thing. All right,
Oh, no.
give another second or two for people to think on this one. And go. What would I write here in terms of intervals for increasing, or excuse me, where f of x is bigger than g of x, or where this pink one is bigger than the yellow one?
Negative 5.38 in bracket, to negative 0.79 bracket.
Nice. I'm glad you used brackets on either end because it's greater than or equal to. So we got to include the endpoints. Keep going.
Union, 1.17 bracket, and then comma infinity parentheses.
Perfect. There it is, right there. Have I been clear, though, that finding these points of intersection is going to be something that I expect you to be able to do on the exam? All right? And that's going to be part of answering questions that follow from that.
Uh-huh.
All right. We're running low on time, so I'm going to skip out on this one and look at the last one. This last one is a great problem because it kind of encapsulates a lot of stuff that we did. And it's not one that requires really any calculation. So let me highlight a couple points here for us. For instance, this point has coordinates of -4 and 6.67. This point, I'd probably do one of two things, ask you to kind of guess at it, or this one. Maybe I'll actually label those on the graph. What does this point look like? What coordinates would you guess on that one?
2.5? No, 3.5. 3.5.
-3.5 and 0. And this one, maybe -2.2 and 0. Okay. This one is -1 and, I don't know, something a little bit less than 5. 4.7, 4.8, 4.9, anything you want as long as it's, reasonable. -1, and we'll do 4.7 because that's what you suggested. But now let's look at the domain here. The domain is your x values, right? That would be everything that's graphed. So that'd be -4 up to 4. And it looks like the point is included at 4. I'm going to assume that it is. So the domain would be -4 to 4 with brackets. How about the range? The range is your y values. Now you should be able to give me some exact values for this.
Yes, the answer.
Go ahead, Lucas.
6.67, -38.25.
All right, so we'll start from bottom to top.
It's the other way around, like a.
Yeah, -32.85 to 6.67. So you're going to go from lowest to highest, right? And the lowest number is given to you on the graph, so it's -38.25, all the way up to the highest y value, which is 6.67. Increasing and decreasing. Let's answer it the way the WebAssign is going to answer it. Let's start out with what happens to this function. A lot of times people get confused. It's not can all of a sudden become increasing just because it crosses the x-axis. It's decreasing from -4 to -3. So I'll start there. -4 to -3. If you want to put a parenthesis around there, on the -4, I'm sympathetic to that. And then what happens to the function?
It increases.
Start increasing until you get to where?
-1.
Yes, thank you, gentlemen. So -3 to -1. And then a long jump for decreasing. Amber, where would it be decreasing from there? You have to answer in terms of intervals along the x-axis. So along the x-axis, -1 to where?
1, 2, 3.
Yeah, so -1 to 3. Wait a minute, I'm sorry, let's see, decreasing, something's looking wrong. Oh, this should be, see, increase, oh, okay, there we go. Yeah, -1 to 3. And then it's increasing again for a little bit, right? Then it starts increasing. And that last little bit here where it's increasing is going to be the interval -3 to 4. Or excuse me, +3. +3 to 4. We'll put a bracket on 4 just to keep WebAssign happy. But there you go.
It stops at 4?
It stops at 4. The graph ends at 4, so we're going to stop it at 4. Local minimum. What's the smallest that this graph gets to in terms of the y direction? -38.25. And the tallest that it gets? 6.67. Now those are the absolute min and absolute max. You do get kind of a couple local mins and local max. So this one would be a local max, for instance, up here. Because the graph is taller than anything near it. So a local max, assuming that we're correct about this point, 4.7. So a local max could be at, if I'm asking for the y coordinate, it'd be 4.7. A local min would be over here at about, -2 maybe. That's because it's lower than anything near it. There's one other local min. Actually, we already got that. So we're good there. Is the function, is the graph a function?
Yeah.
Yes? Now, get the points by answering why.
Yeah. Because of vertical line test.
Yeah, it passes the VLT, the vertical line test. And last but not least, where's the graph greater than or equal to 0? I want intervals on the x-axis. So greater than 0, well, that's between here and here. Between -4 and -3.5, we'll call it. So -4 to -3.5. And then we jump over to here. So in this interval, it's also bigger than, greater than or equal to 0. So union, we'll call it -2.2 to 0. And that's it. That's the last place where the graph is above the x-axis. So a good problem to make sure that you're comfortable with because it involves a lot of the things that we've done here today.
I noticed also that this is labeled old exam, so it's pretty likely something exactly like this will be on the
That could be a little bit of a hint that maybe you want to look at this because I've given this as an exam problem in the past. So nice observation. Thanks, Samira. Probably wise to just skip it. Yeah. All right. Have a good weekend and see ya.